Let's now look at identities and proving identities. So prove each of the following identities. We're given here sine squared x plus sine x plus cos squared x all over cos x is equal to 1 over cos x plus tan x. So we have a left-hand side and a right-hand side, and both of those look a bit complicated, but let's work with the left-hand side first. It looks like we could do a bit more there. So the left-hand side, I can see here that I have a sine squared x on the top plus a cos squared x on the top. And I know that sine squared x plus cos squared x can be written as 1. That's the square identity from grade 11, 10 and 11 that we've done. Okay, so that's sorted out on the top. We still have a plus sine x on the top. We'll leave that there for now. And we have a cos x at the bottom. We'll leave that there for now as well. Right, what we can do now is we can separate this fraction here from one fraction into two separate fractions, because if I look at my question on the right hand side, I have two separate terms. So I am looking to generate two terms here, and this fraction here is only one term. So I will break that up to create two terms. So I will take my 1 and I'll put it over cos x. Then there's a plus sign, and I will take my sine x and I'll put it over cos x as well. 1 over cos x will stay the same because I see that in the question I need a 1 over cos x there. Now, if I look at my sine x over cos x, I know that sine x over cos x is tan x. That's the quotient identity from grade 10 and 11. So if I look carefully now, I have 1 over cos x plus tan x, which is the same as my right-hand side. Therefore, my left-hand side is equal to my right-hand side. Identity is proven. Let's try one more. We have cos 2x over cos x minus sine x. That must equal to cos x plus sine x. So again, let's work with the left-hand side only because it looks like we can do a bit more with the left-hand side. So cos 2x on the top. From the data sheet, that's the double angle for cos, and I know that I have three choices there. So which one do I choose to change that double angle for cos 2? I will choose the cos squared x minus sine squared x one. Because if I look at my denominator in the question, I have a cos x minus a sine x. So this is the one in the data sheet, cos squared x minus sine squared x, that looks most similar to that. So also an interesting fact here is cos squared x minus sine squared x is actually difference of two squares. So that's what I've done in the next line, the numerator of the next line here. Cos squared x minus sine squared x can be rewritten as cos x minus sine x into cos x plus sine x. This is difference of two squares. All over the bottom is cos x minus sine x. And if I look carefully, this bracket in my numerator is the same as the bottom. So I can cancel those off completely. And I'll be left with just what's left on the numerator, and that is cos x plus sine x. And this here is equal to what I have on the right hand side of my question, so the identity is proven. Let's look at one more. We have 2 cos squared x minus sine squared x plus cos squared x, all over cos squared x minus sine squared x, and that must all equal to 1. So here in red, I can see that the sine squared x plus cos squared x again is my square identity, so I can write that as 1 in my next line. I'm working with the left-hand side again because it's more complicated. So on the top here, I have now 2 cos squared x minus 1. All over the bottom, cos squared x minus sine squared x. I know that that answer is cos of 2x here. Double angle for cos. And on the top, 2 cos squared x minus 1. This is also a double angle for cos. One of the types of the double angle for cos, so I can replace that with cos 2x here. So cos 2x on the top over cos 2x at the bottom can both cancel, and I'm left with 1, which is equal to what I have on the right hand side.